So you guys just predicted what the launch angle was by using the initial velocity in both the X and the Y, creating a triangle with tip to tail, and then doing some basic trig. But I want you to compare it to what the actual launch angle is. So I'm going to show you some basic math on how to actually calculate with our setup what the actual launch angle is, which of course you then can compare the two. So if you think about it, we had a block, the length of the block right here, that was inclined above the table, whatever you used. And if you kind of look at this, when I incline it to a certain height, if I pay attention to the very end corner here, that represents the total length and the total height at the end of the block, this creates a nice right triangle underneath the block in between the table. So I've kind of blown that up right here to basically let us know that this is still the length of the block. This is the height at the end of the block, make sure it's the corner, the height that it was lifted up, and it creates a right triangle. So what's really easy actually, if I want to figure out this angle, I can actually do sine of the angle equals my height, which I'm going to write it out because you might confuse it as hypotenuse if I just do h. So that's kind of my fault on writing height. But if I do sine of theta equals the height over the length, I can figure out that angle inside the triangle, of course, by doing the inverse sine or arc sine. But the only issue is that's not actually the launch angle. So if you think about it, the monster popper is going to be fired up and to the right this way. So what I'm going to do on this triangle is I'm going to draw that general direction, kind of right in the middle. I'll line it up actually with this right there. So what I'm trying to actually solve for is this angle above the table, which I know it's not really touching the table right there, but I'm going to do something with this triangle to give you a better visual. So how the heck do I get this angle if I now know this? Well, it's a real easy trick. If I take this initial velocity, which is in the correct direction, if I kind of keep drawing it back through this triangle right here, you'll then notice it actually creates an upside down, if you want to call it that, right triangle. So we know this is 90 degrees. We've just solved for this angle with some trig right here. And this looks like it's the actual launch angle that it gets fired at. So it's kind of cool. Three angles, a triangle's angles need to add up to 180 degrees. So if I know this is 90, I just solve for this one with the trig. I can solve for what the actual launch angle is above the horizontal right here, which is shown over here, okay? All right, we're not gonna do like percent difference, like error analysis, and get too crazy with anything, but of course compare it to what you predicted. If it's within a couple degrees, that's pretty darn good. I think that's a good result to the lab, okay? But make sure you show all your work on this, and hopefully this wraps it up real nice for you guys, okay? Good luck.